Welcome, guys. Thank you for joining in today. We'll be starting shortly. Once it's 7 p.m. CST, the section will kick off. All right, so we're live on YouTube as well. So if you have those who have not registered, they can also join us on YouTube. So let me just put the YouTube link here so that for those who maybe didn't register, they can also join on YouTube as well. So that's the YouTube link. For those who didn't register, you can share it with any of your friends that you know might be interested in this. So they can also stream live on YouTube. All right, so once it's 7 p.m. CST, we'll kick off with this section. So once again, thank you for joining us. We appreciate your presence here. Okay, I see somebody raising hand. All right, so let's see. Can you put your question in the chat section? I see somebody raising. You can just put your question in the chat section. Just a few minutes more, and then we'll kick off. Others will join us. Just about 7 minutes more. All right. So once it's 7 p.m. CST, we're going to kick off. We welcome us to today's session. Thank you for joining. We appreciate your presence here. All right, just 7 more minutes, and then we kick off. So others will join us as they come in. Right. Just 4 minutes more, and then we kick off. 4 minutes more, and we kick off. Right. Just 4 minutes more, and then we kick off. 4. All right. Let me just quickly answer the question from Gills, right? What's the frontier between DevOps and software development? The frontier between software development and DevOps. Right. Let's try and answer them this way. Now, of course, software development is the process of developing, application software, right? And so DevOps is just a methodology by which you can use to automate that process. right? So DevOps, basically, it's the methodology, right, that you can use to automate that software development process. Because, when it comes to software development, there's the commit to production timeline, right? So when the software is being developed and then when it is launched into production, right? So DevOps is just a set of practices, or maybe you can say maybe tools that you can use to, fast track and of course, your software development lifecycle. So it helps you to release, your code more frequently, right? And then if you look at the software, if you look at the DevOps cycle as well, it's an iterative process, right? Which means it's something that is ongoing. It's something that happens almost every time. So the developers within the team, they commit into maybe the test repository or the test branch or the development branch almost every day, right? Every hour, they write, they make corrections, and they commit to that repository. So it's something that goes on, regularly, right? So DevOps is just a set of practice to help to, all right, automate the software development process, and that's why I don't know if you watched the last webinar that we did. I was trying to explain that is the reason why, if you look at your mobile phone that you use, all right, you get updates regularly on your mobile phone, right? You have updates almost every time. You can update an app in the morning, and then in the afternoon there's another update, or for the same app waiting for you. Right. So that's just basically what DevOps does. It helps, organization to push out updates regularly. Regularly. So, and that's why for DevOps, there are a number of tools that as a DevOps engineer, you need to get familiar with. All right. You need a bit, knowledge about, software development as well. And that's why you will see that for DevOps, you find people from different backgrounds coming into DevOps. Right, somebody who is a software developer says, okay, I think I've done a bit about software development. I want to transition to DevOps. So you see people who have done software development, they transition to DevOps. You see people who are maybe system administrators, they transition to DevOps. You see people who are network managers and network administrators, they transition to DevOps and all of that. So DevOps is just basically, a process that helps you to automate that process in a faster, all right, and more accurate manner, right? You want your software development to be efficient. You don't want to leave room for any kind of errors or any kind of mistakes, right? Like in the traditional approach, where there can be a lot of mistakes, but with DevOps, there are different stages that your software development will go through, right? So there's this testing phase, there's different phases that your software development will go through before finally committing, such to production. Right. I don't know if I answered your question, but if it is not clear, you can just signify, or you can put it in this chat section. All right. All right, guys. It's time already. So okay. All right. Yeah. Hello, everyone. We welcome all of us to this live webinar. All right. Okay. Well, software engineering, well, I wouldn't say software engineering is a part of DevOps, right? Now, DevOps is a different field, right, that came about as a result of, some of the issues you have between development team and, and the operations team, right? So the DevOps person is just in the middle, right? Just helping. Oh, okay. Apologies about that. All right, how about now? Is my voice better now? Sorry, I think I have cold, so that's why this voice seems to be like that. So apologies for that. So software engineering, we can't say software engineering is part of DevOps, right? But then when you talk about DevOps as well, you are also, it's a form of, how do we call it now? It's just like a process by which you set up infrastructure that enables, right, software development in an efficient manner. All right, so software engineering, that will be for those that are into full-time development, right? The full-time developers, all right? Those ones are the ones that will be involved in software engineering, right? But DevOps, basically, the idea about DevOps, what you do as a DevOps engineer is that you set up the pipeline, right? The infrastructure, right? That will ensure that the code that the software developers are developing, all right, moves from the commit state to the production phase in an efficient manner, all right? So basically, that's what the DevOps engineer does, right? So as a DevOps engineer, you are in charge of the infrastructure that ensures that the code that the developer has developed, that has been tested, moves from that development phase, right, to the production phase. So that stages, right, the processes that that software is going to go through is what you as a DevOps engineer is what you are responsible for, right? So you are responsible for the infrastructure. And that is why when you talk about DevOps, you talk about, of course, you must be familiar with Linux operating system. You must be familiar with Git, for example. You must be familiar with Docker, Kubernetes, and all those things. And that's why for DevOps as well, you talk about monitoring, right? So because after you've set up the pipeline, and then the code has moved from development phase to the production phase, right? You need also to monitor to ensure that the code is behaving, right, the way it should behave, or is performing the way it is expected to perform. All right. So that's just basically what DevOps is. So software engineering is just basically for those who are into full-time, software development, right? That's for that. So we can't say that software engineering is, is part of DevOps. So DevOps is just basically the infrastructure, right, that ensures that the code moves from development to production. That infrastructure is what the DevOps engineer ensures that is effective, and then there are no issues, right? All right. So let me just record here so that as we are live streaming, and then we are also recording so that people who maybe missed the section can, of course, have access. All right. Thank you very much, sir. Thank you for that comment. All right. So, so we are recording as well so that for those who, couldn't join us today, they can as well, get a recording later, and then they can watch it on our YouTube page later on. And we are also streaming live on YouTube as well. So if you have people, well, you didn't miss anything too much, all right? You didn't miss so much, but of course, we're just getting started. All right, we're just getting started. Thank you very much for coming once again. My name is Oluwaseun, and I'll be walking us through, this architecture that we have here today. That's basically what I'll be doing. I'll be walking us through the architecture that we can see on my screen. That's what I'll be doing today. All right, so okay, we'll answer any other questions later on, but let's just move quickly because of time, so that we don't, because we understand that we're in different time zones, right? And we don't want to waste people's time unnecessarily. So now this is what we're working on today. This very simple architecture, but of course there's a lot that you have to do in order to make sure, or to ensure that this architecture, is deployed, right, in your environment. So basically what we want to do is we have, an application that has been developed by our development team, right? And then we want to use Jenkins, which is a CI/CD tool, right? Code integration and code deployment tool. We want to use that to deploy, right, the application. We want to package the application into a Docker image. And then from a Docker image, we want Jenkins to deploy that same architecture, right, that same image on our EC2 instance on AWS, right? So basically what Jenkins will be doing for us is, number one, it will fetch the code, all right, from the GitHub repository. Number two, it's going to build, right, that application into a Docker image. That's the second thing. And then the third thing Jenkins is going to do for us is that Jenkins is going to also deploy that image, all right, onto our EC2 instance, and then start that image up and then turn it into a container. So there are two things we want to look at we're going to be looking at Jenkins, all right, deploying a single image onto the EC2, right, running a single image on the EC2. And then we're also going to look at Jenkins, right, helping us to deploy what you call a Docker Compose. All right, so we're going to be explaining some of these terminologies. The Docker Compose basically is that, you know, you want to run more than one container. So you have 2 or 3 images that you want to run, right? And then you don't want to run them independently, right? Or one after another. You want to run everything at the same time. That is where you use your Docker Compose. All right, so let's see what we have now for the benefit of those who maybe new to DevOps, for the benefit of those who will be new to DevOps, and for the benefit of those perhaps that want to transition into DevOps. And then we're just going to make some clarifications before we go into the console to practicalize what we have for today. So let's see a few definitions, a few things that I feel it's important for us to understand before we delve into the console. Now, again, this is the architecture that we're working on. And so let's just quickly, yes, this architecture can run in an on-premise environment. Absolutely, you can do that in an on-premise environment, yes. All right, so let's define a few terminologies here. Now, before Docker containers, right, let's look at a traditional approach before the event of Docker containers, right? Before Docker containers became popular. So how were we doing it, you know, right? How were we running our application? Right, yep. So before, right, Docker container became, you know, prominent, that everybody today is talking about Docker and all of that. So what was it like before Docker? Let's look at this image here. Now, if you look at this image here, we have 2, you know, PCs. So there's one that is the developer PC, and then you have the production server, right? Now, so you have the developer, then you have the IT operations. Now, this was before DevOps, right? This was before DevOps. So you have the developer. So basically, the developer is somebody who is a software developer who develops the code, maybe for the organization or for, you know, for the organization, basically, right? And then you also have the IT operations. Now, the job of the IT operations is to take the code that the developer has, you know, developed, and then take it to the server. It can be a test server, it can be a development server, but I just wrote production server here just to, you know, explain things to us. Now, the job of the IT operations is to run that application in, right? It can be the test environment, it can be the development environment, it can be the production environment. Now, that's the job of the IT operations. But then there were issues, right? Because the issues, you know, ranges from the fact that now, as the developer, now before Docker containers, now if you look at the PC that you have right here, now basically, if the developer is developing a Python application, for example, or maybe a Java application, for example, right, the developer is going to have to install Java on the system. You will have to install different dependencies, right? You will have to install different dependencies on the system, all right, in order to run the Java application. So if it's Python also, you will have to install Python on the system, and then, all right, and other dependencies. Now, the challenge is this. Now, this developer is using Windows 11, for example, right? It can be any operating system. It can be a Mac, it can be a Linux. So this developer is using a Windows 11 operating system. And so now the setup for Java, all right, on this PC is going to be different from how you would set it up in Windows Server 2022, right? But then the developer succeeded in installing all these applications, you know, this Java runtime, all the dependencies on the system. And so every of the application that he has developed, according to him, he has done the test on his own system, and then he has, you know, certified that, oh, this thing is working. But then it gives the same application, right? It packaged the same application and gives it to the operation guy, and then that one takes it to the production server to run it. But there was an error, right? The guy couldn't run it. So there's this issue between the developer and the IT operations, saying, the developer is saying, well, I tested it on my system, it worked well, it worked fine, I don't have any issues with it. But the IT operation is saying, the same application you gave to me, I run it on this production server, it's throwing up an error, something does not seem to be working. All right. Now, this was before Docker container. This was before DevOps, right? So that issue, was an ongoing issue. So this person is saying, I've run it on my system, it's working. This other person is saying, well, on the production system, or on the test system, we can't seem to run this application that you said you have tested. All right. So that was before Docker containers. Now, so how was this issue resolved? Now, Docker container came into the picture, and then you have the same set of people, the developer, the IT operations, but then something changed. Now, what changed? Now, instead of the developer, in this case, to now install, right, maybe the Python runtime or the Java runtime, or locally on the system, the only thing the developer needs to install, right, is just the Docker runtime, right? On the production server as well, you have the Docker runtime. Right, so you will see that the thing that is common to all of them now is that they all have Docker running on both systems. So with Docker running on both systems, whatever you do on the development system and you package it with Docker is also going to work, right, on the production server or on the test server. So with that, everybody is cool, right? So the developer tested, everything is fine. The IT operation takes the Docker image as well, run it on its production system, everything is fine, right? Because there are a lot of things that comes with a Docker image, which we're going to be breaking down shortly for us. But what I'm just trying to explain here is that with the Docker container, right, with the Docker container revolution, it makes development easy, right? The argument is no longer there, all right, because everybody now has the Docker runtime on their system. So whatever development they are doing, they are leveraging the Docker runtime that they have on their system. So there's no argument again. So whatever Docker image that you run on system A, all right, is going to also work on system B. Okay, that's what Docker has done for us. Now let's explain this Docker thing a bit further, right? Let's explain it a bit further. Now let's look at this let's look at this image that we have here. We talk about Docker container, Docker container, Docker container. Now let's look at this image that we have right here. Now, what does this image tell us? Now, this Docker idea came about, as a result of this ship that we are seeing, right? You can see that there's a lot of container on the ship. The ship is, of course, it moves in an ocean from one destination to the other. So now, how can we use this to explain the concept of Docker, right? So let's look at this image critically. Now, there are three things that we have here that I want us to look at. Now, there's the ocean, right? There's the ship, all right, which sails on the ocean. And then on that ship, there are containers on that ship. So let's do some comparison, right? Let's do some comparison. All right, now there's the ocean. Now that ocean, if you look at it critically, can also be your PC, all right, which is your computer system, right? So the ocean can also be your PC, so which means you have a system, right? So your PC can also be, right, the ocean. Now let's look at a few other things. Now, the ship in this instance is your operating system, right? I'm trying to break down this Docker thing for us, all right? The ocean is your PC. The ship that is sailing on that ocean is your operating system. Now, operating system here, it can be Mac, it can be Linux, it can be Windows, right? But that is your operating system. Now, if you look at it again, you have containers on that ship. Now, that container you have on that ship is what you can refer to as the Docker, right? That's the Docker. Now, if you look at the concept of this thing, the container that you have on that ship, right? It's not just one container, there are several containers there. So which means if you have the Docker runtime installed on your system, you can actually run multiple containers, right? So which means in the traditional setting, I have to install Python on my laptop. And then if I have Python installed on my laptop, it may be difficult to have other installations on my laptop. But with Docker, I can install, all right, I can have a Python container running on my system. I can have a Java container running. I can have a Node.js, container running, right? Different things can run. So if you look at the same container that we have on the ship, now this container, of course, definitely they don't contain the same item, right? They contain different goods, all right? But of course, they are still on the same ship, all right? So basically, that's the concept behind it. So the ocean that the ship is sailing on is just your PC. Now, your PC, on top of your PC, you have an operating system that you have installed on it. All right. On that operating system, you have a Docker runtime that you have installed also on it. And on that Docker runtime, you can have different containers and different images that you can spin up at any time that you want it. All right. So basically, that's just the concept, about Docker. So let's move quickly. So now the question you may want to ask again is, so how do I, create my own Docker image? Because definitely your Docker runs, all right, it's actually an image, right? You have an application that you have packaged, all right, and then that same application, you need to package it into an image, all right, and that's where the Docker file comes in. Now, what is Dockerfile? Now, let's explain this Dockerfile again, using the concept of the container. Now, I'm sure most of us, we've ordered a few things online before. Maybe you've ordered pizza online, maybe you've ordered food, or maybe groceries, or maybe furniture or anything. You've ordered something online before, right? Now, if you order anything online, the order comes with what you call an invoice, right? On that invoice, you have details. Okay, so you have details like this item is from so company, it is being shipped to so place, and then you now have a list of the items, right, that the invoice contains. Now, if you look at the Docker file as well, it's also the same thing. Now, your Docker file can be likened to an invoice that comes with whatever it is that you have ordered. Because if you look at the Docker file also, the first thing you do is to say from. Now, this from here is basically saying, what is the image that you want to use to run your application? All right. So this application that you want to run, this application that your software developer has written, what is the image, right? What is the what's the base, right? Like the operating system kind of, or the application that this software runs on top, right? So you have to define that. The work directory is basically saying, this is where this thing is going to, right? This is where we're going to be working from. So if you look at your invoice, on your invoice also, you have from this company to this company, right? So from, okay, you define the image. Now, all of these images, there are things you can get on the Docker, or which I'm going to show us shortly, right? And then you have your work directory, which is basically saying, inside of this container or inside of this image, this is the work directory, and then you have your copy. Now, all this work directory, all this copy that you have, you can liken them to the items that you have on your invoice. So basically, what we are saying with the Docker file is saying that, we have an application we want to run, but this application will run with this, all right, with this kind of application. So if it's a Node.js, you need a Node.js image to run that application. If it's a Python application, you need a Python image to run that application, right? And then you now list the things that you want to do, all right, with your Docker file and then with your application that your developer has, programmed for you. All right, Nitin Sahani. Okay, somebody's raising up his hand. All right, let's take that. All right, please go ahead and you can unmute yourself and ask your question, please. Nitin, if you can hear me, you can unmute yourself and ask your question. Okay. All right, so the person is not here. Or you can put your question in the chat section as well. All right, now, so that's just basically the idea about the whole thing. Now, the slide is just for us to get a bit understanding about the Docker, how it works, and all of that. So now let's go, let's look at an application that we're going to be building together. All right, let's look at an application we're going to be building together. So let me share my screen and show us this. All right, so I'm sure this should be visible. Now, this is a React application, right? A Node.js React application, right? So our software developers, they came up with this software, they developed it. The software basically, it's an application that would get people maybe data, maybe like a registration form, right? Let's just say like a registration form. Now, this application, it's a Node.js application, right? Now, in order for us to run this application, we need to define our Docker file, right? We need to define our Docker file. Now, this is our application. We have the API section and then we have the app section. So our developer, they've tested it, they've checked it, everything is working locally. So we need to now move this application from the local, right, from the local system onto, let's say, our production server. So what you want to do now, in order for you to be able to package this application right here, is to now define what you call your Dockerfile. Now, this application, it's an application that is written, using Node, right? Node.js, right? So we need to use Node.js to run it. So the question is, how do I get this Node.js? That's pretty simple. Now, what you do is you go into, let's see how we do that. Let me share my screen with us so that we can see. Just a minute. Okay. All right. So now what you do is that you go to Docker Hub. That's where you can find all the images. Docker Hub is a public repository where you can find whatever Docker image that you're looking for, right? That's where you can find any Docker image you're looking for. Okay, so, okay, I was logged in actually. So let's see. Let me just sign out of this place. And let's see all right, so now this is the Docker Hub. So if I want to search for any image, let's say I'm looking for, my developer has told me this application was built using Node.js and all of that. So I can just come here and type in Node. I'll just say Node.js and then search. So to give me images, different images, right? So, so if I look at this place, I have Docker Node.js, I have different images right here. All right, now if I type Node, let me just say Node, instead of Node.js. All right, now, so this is the Node image that I was looking for. So if you look at this, it tells me that this is the Docker official image, which means this is the correct image. If you look at it, it was updated 2 days ago. And so far, they've had over 1 billion plus downloads, right? Now, if you click on this image right here, you have different, what you call tags. Now, the tags is just a way to identify the different versions, right, of that image. So if I go to tags, I will see different images, right? This is the latest version that they just published. And that latest version, this is the vulnerability. After it has been scanned, there are 5, medium-sized vulnerability, about 106. It can be classified as low and all of that. So these are the different versions, all right? Just like you have your, your application version and all that. So these are the different versions. Now, what you would do basically as a DevOps engineer is that your developer, of course, they must have informed you, oh, this application that we're developing or we have developed is written in Node.js, and then they will tell you the version of the Node.js that they used. So your own job is to come here to the Docker Hub, all right, type in Node, and then these are the different images. So for example, if they tell you, oh, the application that we've developed, we used, Node.js 20, Alpine 3, blah, blah, blah. All you need to do is just to copy this tag here, and then you go back to your Docker file, and then just type in Node, all right, column this tag right here. So that's why, if you look at what we have here, we have Node, and then we have column 10. So basically, we're looking for Node 10. So our developer has told us, oh, this application that we just developed was written in Node, and then the version that they used is version 10. All right, and then we put in all of these parameters. So we're building the UI, all right, which is the user interface, and then we are setting, right, the work directory. So basically, we are saying if this image should be run anytime, right, then this should be the work directory. So basically, this will be where all applications will be copied, right? And then what are we doing with this? We are copying, right? What we are copying is this. We're copying this folder, all right, into, all right, this work directory that we have right here. So this dot means the present directory, and then we're copying something into this location, all right? So that's what that means. And then run means that, okay, once you have copied it, then you can run this set of commands, all right? We're going to see all of these things shortly. So we're running this set of commands. And then the next thing again is based on what the information we got from our developers, All right, we also need to build up the server, so which is the back end. So this UI build is basically the front end, all right, of the application, all right, that our users can interact with. And then we also have, okay, I'll answer that question shortly. And then we also have the server backend that we are building. And then we're saying the work directory for that should be the root. And then we are copying from this UI build, right? We're copying from the UI build all the things that we have copied, all right, into the UI build. We are transferring them into, all right, our root folder in this particular location. And then now we are copying this API, right? This API folder, we're copying it, right? We're copying everything, we're copying this package JSON basically into our root folder right here. And then once it is copied, we're saying, you know what, just change directory to this folder and then do npm install. So basically we want to run our application. And then once it has been installed, we are saying again that copy this server.js that you can find right here, which is this, copy it again into this API folder in this root folder, all right? And then the port that our application is going to run on is actually port 80, all right? And then we're saying, now this command right here basically means that anytime this image is being run, right, which means we want to run the image, and then, so when you run an image, that's when it becomes a container, all right? When you run an image, that's when it becomes a container. We're going to see all of that shortly. Now, so we're saying that anytime this image is being run, then execute this command, which means start the application that we have packaged, and then our users can access that application. All right. Now, to answer the question, can we build Dockerfile from scratch, or there's a pre-written template? Yes, you can build Dockerfile from scratch. You can build your own Dockerfile from scratch. All of these things are just basically what Docker uses, right? So you have to define your from. That's the first thing you do. What is the image that your application is running on, right? Is it a Python application? Is it a Node.js? Is this, whatever the application is, whatever programming language that the application is that they use, you have to specify that. And that's why if you look at the Docker Hub repository again, you can actually find anything here. So if I'm looking for Python, I can just type in Python image, and then, so right here I have the Python official image. So that also has about 1 billion downloads already. So if I click on it, so I have different Python versions. So if my application has been built using Python 3.12, all I need to do is just to, all right, copy that, and then my Docker, once I run the Docker file, it's going to pull, right, from the Docker image. Now, all these images that you have here are public, so anybody can make use of them for their own use, right? But all these images, of course, you can also, if you click on any of them, I think you can also, it will take you to the GitHub repository. It will take you to the GitHub repository where you can see how that image was packaged. So it's really some kind of programming. So you don't need to have this level of knowledge, all right? All you need to do on your own is to just get the image and then put it in your own Docker file and make use of it. So yes, you can build your Docker image from the scratch. All right, now, in order for us to run this application right here, because what we are doing is we are not running this application locally, right? We want Jenkins to do the job for us. So which means we're going to need to configure a Jenkins file, right? We need a Jenkins file, and then we need a script.groovy file, right? Now, what is a Jenkins file? For the benefit of those who maybe are new to DevOps or are just starting out. Now, if I go back to the architecture that I showed us earlier, I mentioned that if I go back to that architecture, let me go back to that architecture. So if I go back a bit to that architecture, now what we're doing is we're using Jenkins to do all of this automation, right? So what we're going to do now is we're going to commit our code into the GitHub repository, and then from the GitHub repository, Jenkins is going to fetch that code from there, and then Jenkins is going to run the image. All right, it's going to create the image for us, and then it's going to deploy it into our EC2 instance, all right? So that's what we want to do. So now let's look at how we can create a Jenkins file in order for Jenkins to be able to run our application for us. So we need a Jenkins file, so we can click here, all right, can click on this place, and then, sorry, so let me just click out. So here, so you type in your Jenkins file right here. Okay, now when we need to start typing Jenkins file. Now, basically, when you're writing your Jenkins file, which is what you use to do your pipeline build, right? The Jenkins file is what you use to do your pipeline build. Okay. Now, what you need to do is, first of all, of course, you must have your Jenkins server installed. We may not be able to go into that today because of time, because as much as possible, we want to try and, make sure that the video is not too long, all right, so that people can watch. So basically, if you look at my own environment here, let me just show us what I have. I already have a Jenkins server up and running. And one thing also you must also notice that you can also run your Jenkins as a Docker image, right? You can also run your Jenkins as a Docker image. Okay, my login has expired. So I need to log in again. Let me just log into my AWS account. Then I will need my MFA code to authenticate. All right, let me just grab that quickly. So the first thing you want to do is that you must have a Jenkins server set up already on AWS or on any cloud platform of your choice. But of course, we are using AWS for our own demonstration. All right, but of course, whatever it is that we do on AWS, you can also try the same thing on Azure or DigitalOcean or GCP, whichever cloud provider you may choose to use. All right, so I have a Jenkins server right here that has been stopped. So let me start it up right now. And then my Docker server also installed. So let's start both of the servers. And I'm going to be showing us how we can log into all these servers and see it in action. All right, so while they are starting up, let's start building our Jenkins file, because we're going to need that Jenkins file, all right, to push to our repository so that by the time we create a pipeline in Jenkins, all right, it should be able to build, right, this application for us and then publish it into our EC2 instance. Now, when you're writing a Jenkins file, it looks, it's written in JavaScript object notation. So there's a lot of curly braces, a lot of commas and all that. Now, the best way you can, write your Jenkins file is to use what you call a script.groovy file, right? A groovy file. Now, that groovy file helps you to do some kind of abstraction. Okay, so if I want to write my Jenkins file, I can do def and then just do gv. So basically what I'm saying is I want to use a Groovy script or a Groovy language, right? The Groovy language is just a derivative of Java, but a simplified version of Java, right? So let's do dev gv, and then let's start our pipeline. Now, the pipeline that we want to do is basically, we want Jenkins, right? Jenkins is a CI/CD tool, and then we want Jenkins to build this application for us. We don't want to build it locally, all right? We want Jenkins to build, all right, this application into a Docker image. And we want Jenkins to do another job again, which is to take that image, push it, all right, into our EC2 and run the image for us by itself. So that the only thing we are just going to do is to go there and then, access our application. All right, that is basically what we want to do. All right, so let's see how this whole thing would work. All right, let's see how this whole thing would work. Now, you can write your pipeline here. So basically, you can do pipeline, all right? And then you put it there. So agent, you can say your agent is any, all right? And then the next thing you want to do after the agent is say stages. Now, in Jenkins, you have to define your stages. Now, there are different stages. Like I said earlier, you have the build stage, you have the test stage, you have the deploy stage. So we need to start defining the stages, and then we need to tell Jenkins what each of those stages should do for us. All right, so you need to tell Jenkins what each of the stages should do for us. All right, so pipeline is, all right, and then we have stages. All right, and then stages again, another curly brace, enter. And then the next thing you want to do, all right, is that you want to say, all right, now the first stage, now don't forget what we have there is stages. And then the next thing we want to have now is to start defining the stages that we want to have. All right, so the first stage will be basically an initialization stage, all right, just to initialize our Jenkins script. So now the first stage is defined. So we need to put another curly braces. All right. Now, after that, you need to now define the steps. So what is the step going to look like? All right. What's the step going to look like? All right. What's the step? So you put another curly brace again. Now, these things are not difficult, all right, but I just chose to type it out because I could just copy and paste something there and then walk you through what I just want us to do together so that you can see what the Jenkins file looks like. So now from here, you can now begin to define your scripts. So which basically is what you want to do, all right, which basically is what you want to do. All right, let me see, maybe I should just copy somewhere so that we don't waste time typing it out, and then I'll just explain to us what it is. Let me see if I can get it here. Just a minute. Okay, so let me see if I can just get it. All right, so I can just copy this. And paste here. Now, this is the script that we're trying to type out. All right, this is the script that we're trying to type out. So let me just copy, let me just close this one. Now, basically what we are saying is that now the first thing we want to do is to initialize, all right, and then the script, so we're just echoing, right? This one is just echo, just a message. It doesn't really mean anything. Now, we're going to have a Groovy script, all right, that we want Jenkins to load up at startup, okay? Now, the Groovy script is not here, but I'm going to put it here. I'm going to put it into it shortly. Now, the next stage is that we want to build. No, so what do we want to build? We want to build the Docker image into a Docker file. All right. Now, this gv.build that you have here is basically what you have in the Groovy script, right? And then this is a function that we are calling, all right? We're going to see that shortly. The next stage is that we want to push, all right, the image that we have built. You want to push it into, all right, a Docker Hub repository that we have created online. And then you also want to deploy the same thing to an EC2 instance, right? So that's like 3 steps or 4 that we want to do. So we're initializing, we are building our image, we're pushing the image to Docker repository, and then we are deploying the same image to an EC2 instance. Now, this gv.deploy, all these things that we have here, somebody may want to ask, okay, so where do we get it from? All right, so that's pretty simple. Let me copy the one I have here because of time. And then let's put it. Okay, so let's just put that here and paste it. So now I have my script.groovy here. So let's walk through this thing together. Now, the first thing we want to do is we want to build an image. So in this inside of the script.groovy, we have, all right, defined a function. Okay. Now, what is this function going to do? The function is going to execute all these things that are underneath it, right? So the first thing is that this function right here is going to execute this. So what this function is going to execute is going to do an echo. So an echo basically just a message, and then we're going to have a shell. So which means we want to execute some commands, right? So we are building. So when you want to build a Docker image, you do Docker build, and then this -t basically is to tag the image, and then we are building this hub, right? So this is just basically the name, all right? Now this name that you have here is actually the details of my own Docker Hub repository name that I'm using here. Now you see the small dots that you have right here. The small dot signifies that there's a Docker file in this current directory. That's what that small dot is. Now don't forget, this is the image, this is what we're trying to build, all right? We're trying to use the Docker file to package this application, right? That's what we're doing. So this application, these two folders, that's our application folder. So we're using this Docker file to package these two applications. So inside of my script.groovy, I just put a dot here. So the dot here means that a Docker file is present in this root directory or in this present directory. That's what it means. Now, the next thing I want to do is that I want to push the image to a Docker repository online. All right, you could push your image to an ECR as well. For those who are using Amazon and all that, you can also push to ECR too, right? But I just choose to push to a Docker Hub repository. So I'm going to show us all this credential thing, how you can get these credentials, right? Because I'm referencing my Docker Hub, right, password on my Jenkins Server. And then I am pushing right here to my Jenkins Server. All right, now let's log into our Jenkins Server so that we can see all of these things in action. So let's start up our Jenkins Server. So I'm just going to click down here, and then I'm going to open up this terminal right here. All right, I'm going to open up this terminal. So the terminal is loading, and then I'm going to split this terminal into two. I'm going to do a split. All right, so basically I want to have my Jenkins and my Docker server connected from this point. So here I will rename this one. So let's rename this Docker server. All right, and so let's rename this one Jenkins server. All right, so now we need to log into our instance. So if I go back here, of course, yes, the video is going to be available on the YouTube page, right? So after the class, we're going to post it on our YouTube channel, so you can go to the YouTube page to get the video. All right, noted. We'll get a link across to everyone. All right, and then you can also, I'll send you the before the class ends, I'll send the YouTube link to you so that as soon as the video is posted, if you subscribe, then you can get a notification once the video is available on the page. All right. Okay. Now, so let's go to our console and let's get all these credentials that we need. So my Jenkins server is up and running. So what do I need? This is the IP address of my Jenkins server. This is the IP address of my Docker server. Now, for those that may be familiar with AWS, you already know that before you can deploy an EC2 instance, you need what you call a security group. All right. A security group is a stateful firewall that enables you to do some kind of operations. Basically, it allows you to define what is allowed into your instance or into your server. Now, when you're creating a Jenkins server, your Jenkins server operates on port 8080. So which means in your security group, you must have your port 8080 opened up. So if I go to security, yeah, we're going to share the GitHub repository. Absolutely. So when you go to security, right, underneath here, I have my security group connected here. Now you can see that I have all of these ports opened up. Now, how do I get to this place? Let's just do a quick lecture on security group. So if you scroll down from here, you can go to security group. All right. And then from here, you can click on create security group. You give your security group a name, whatever name you want to give it. So we can call this Jenkins SG. And then we can just say allow traffic from AT. All right, we'll choose our VPC. Now, all of this information are things that in our upcoming class that we're starting later this month, these are some of the things that we're going to go in depth into. All right, but of course, for the purpose of this training, we're just going to try and go as fast as possible so that the video is not too long, so that people can watch and then follow. But for those that may be interested in the class, you're free to register. We're going to share the link to the website with us. You can go there, check the content. If you are convinced, you can just go ahead and register. All right, so here you specify your inbound rules. So if you're doing custom TCP or you are doing an HTTP traffic, you can choose HTTP, and then you specify. So 00 here means from anywhere. So which means if you choose 00, which means anybody can access your Jenkins server from anywhere. All right, so once you're done, you click on save, and then you go back. So that's how you create a security group. All right, now my Jenkins server is also up. If you type this public IP address on your web browser, you may be able to access my Jenkins server, but of course you won't be able to see it now because I've not started the Docker container for the Jenkins yet. So I need to do that, and we're going to do that together. So for the Jenkins server, let's connect. So this is the Jenkins server. So I'll copy it. And by the way, this Jenkins server is running on a Debian Linux operating system, right? It's running on the Debian Linux operating system. Okay, so I have copied that. Now on AWS, when you're dealing with AWS, you have, when you create a server like that, you have what you call a security group. Sorry, a key pair, right? So once you create your key pair, you download a copy on your own system. And then with the one you download on your own system, you authenticate with your server that you have online. So anytime you want to do anything on your server online, right, you authenticate. Okay, thank you, Amma, for that. Thank you very much for posting the GitHub page. Now, this code that we're even working on is actually available on the GitHub repo, so you can go ahead and just download it now if you want to download it. It's actually available. They are published it there already, so you can just go there and get the code right away. All right. So let's log into our Jenkins server. So the first thing I want to do is I need to change directory to where my key pair is. All right. So CD, I have to change directory. So my key pair is right on my desktop. So I'm in my desktop directory. So what I need to do is SSH-I interactive mode, and then the name of my key pair. Then I'll press my tab key to just auto-complete it for me. So since my key pair is in that current directory, and then now since I'm using a Debian, right, the Debian Ubuntu Linux, my username is admin by default, and then right, the IP address of my Jenkins server, and then I'll press enter. Now, this thing that you see here, if you look at this error message that you see here, it brings out this, anytime you want to authenticate to a server online, it shows you, right, this kind of thing, and then it asks you to say whether yes or no you want to continue. Now, our Jenkins is also going to have the same problem, but there's a way we can bypass this, because on Jenkins, when Jenkins is running the pipeline, Jenkins cannot be answering yes or no, so we need to find a way to bypass this in Jenkins. But for now, let's just go ahead and say, yes, we want to authenticate into our instance. So right now, I am inside of my Jenkins server. So I need to start up my Jenkins. Like I told you, my Jenkins server, I didn't install it directly on the system. I actually installed it as, you're right, is a Docker image as well. So if I do Docker PS, right, so Docker PS basically means I want to check what containers are running. And then -A, I want to check containers that are not running as well. So if I press enter, so right here, all right, so now there's something that I've not done. So I need to do that before I can check that. So I need to do sudo su. So basically, I'm trying to upgrade my permission to super user. And then I need to type in something right here. You don't bother about this. in the course of the class. For those that register, we're going to talk about all this in depth. Okay. Okay, so let's do Docker PS -A. All right. So now that shows us the images that we have right here. So it shows me these are the containers that I have stopped. So my Jenkins container is this one here. So I need to copy. All right, I need to copy that. And then I need to start it up, right? I have stopped it. So right now I need to start it. So how do I start it? So basically the command is simple. You just do Docker start, right? So that's the container ID that I've copied. So I've copied the container ID. So I'm starting up the container. Now the container has started, but of course there are a few things that I need to do because my Jenkins should be able to also run some Docker commands by itself, right? Without anybody going there to do anything, because that's the purpose of DevOps. You want to automate every of your processes as much as possible, right? You don't want to do any kind of manual operations. So what I need to do now is I need to log in into my image or my container rather. All right, so I'll do batch. And then if you want to log in into a running container, this is how you log in into a running container. So you exec, so IT, so interactive mode, and then I'll do -U and then 0. So what this means is I want to log in into this container, right? This running container as a root user, all right? That's what this command means. So if I press enter, right here, I'm inside of my container. So if you look at it, I have root. This is the container ID. So it has changed from, it was IP before, but right now, this is my container ID. And it has changed. So the next thing I need to do is just to do some kind of permissions so that Jenkins can run Docker commands, right? So I need to do all these things here, Docker sock. All right. So that's the only thing that I need to do. So the reason I did this is because I want Jenkins to be able to run Docker commands, all right, by its own self. So I don't want to be assisting it to do anything. So Docker, if we do Docker PS now, so our Jenkins container is running right now. So if I go over to my page here, all right, if I go right here, let's get our IP address. So these are IP. All right, so let's paste that here and then column 8080 has been opened up on our security group already. Right, so our Jenkins server is started. So let's log in into the Jenkins server and then let's start building some stuff. All right, now the Jenkins container has been created prior to the class because if you want to set up your Jenkins server, it requires quite, it's something that takes time. So if we're going to be doing that in the course of the class, we're going to have to use the whole day to do that. All right, so it's been created prior to the class, but of course, for those that will be joining our class that will be starting later this month, those are some of the things that we're going to be walking us through. All right, and the reason why we are doing these free classes is because we just want people to get familiar with what the class is going to look like so that then from there, they can now make their own informed decision. All right. So now these are Jenkins, right? We have a few pipelines here, but of course, we're going to be running our own shortly. Now, Jenkins has been started. The next thing we want to start now is our Docker server. So the Docker server has also been started. So we need to copy the IP address and go over here again and go to our Docker server and log in into that also. So that also we need to change directory to desktop, which is where our key pair is located, -hi, and then we can do dev, all right? So this is our key pair. And then, so the Docker server is actually running Amazon Linux 2023. So the username for that is EC2-user. Then you do your @ and then you paste in the IP address and then you press enter. So it's asking us the same question it asked us when we're trying to do the Jenkins. So we just say yes. And then our Docker server is also up and running. All right, so if I look at it here. Now, on the Docker server, there are two things you need to do on the Docker server, right? On the Docker server, you need to have your Docker runtime installed. Remember the image that I showed us? Your Docker runtime should be installed. So I have also installed my Docker runtime. So if I do Docker version, all right, so that should show me the version that I'm running. So I'm running version 20.10. So Docker is installed. Now, if I also do Docker compose, which is one of those things that we're going to be doing together as well, Docker compose version. So you can see that I also have Docker compose installed. So those are the two things you need to install, and you can install that, or you can follow this documentation right here. Right, this is the documentation on how to install Docker. So you can see that they have for different operating systems. So if you're using, right, if you're using Ubuntu, if you're using, I think they should have for Windows as well. I think, okay, Windows uses the Docker desktop, all right? So the Docker desktop, that is for Mac and for Windows. I think Linux also uses that, okay? So you can go through these documentations right here, and then you can follow it to install the Docker on your own system as well. All right, so let's go back to our server. All right, so Docker is right here, is installed. So our Jenkins server is up, our Docker server is up. Now let's check our Docker server. Let's see if we have any container running. So if you want to check that if there's any container that is running, you can do Docker PS. So right now I don't have any container running. So if I do Docker PS-A to check if there are any Docker container running that have been stopped. So I don't have any running as well. So if I do Docker images, just to check if I have any images right here. All right, so I have 4 images that I have downloaded here. But of course, I can delete those images if I don't want them again. So if I want to delete any of this image, now before you delete an image, well, you must ensure that you don't have any container that is running that is using that image. All right, you must take note of that. Before you delete a Docker image, you must ensure that there are no Docker containers that are using that image currently. All right, so if there are Docker containers using that image, the first thing you want to do is to stop the container, all right, delete the container, and then you now remove the image. So right now in our own environment, we don't have any container running, we don't have any container that we have stopped. So I can easily delete the image. So I can just do Docker RMI. So RMI just basically means remove image, right? Remove image. I want to remove image. So there are 2 images I want to remove. So the first one is the demo app, and then the tag is React Node.js app. And then the second one here is it's just the same thing. So I can delete 2 images at a time. So the second image that I want to remove is to avoid any confusion. That's why I'm removing all these images app. And then we have Node app, all right? Okay, so our images have been removed. So if I clear my screen now and I do Docker images, you can see that I have just 2, all right, images there. So we can even remove these ones too. So let's just do Docker remove RMI Mongo. So we do the tag latest, and then we have Mongo Express. So the tag is latest as well. All right, so that's also been deleted. So if you clear, so right now, if I do Docker images, so you don't have any images there. All right, so that's been done. Now, the next thing we want to do is to commit this, our code right here that we have written into, all right, is to commit it into our GitHub repository. All right, so we need to commit this into a GitHub repository. So we just need to check again if everything we have written here is okay. All right, so everything seems fine. All right, so let's commit it into a Git repository, and then we're now going to go to Jenkins and then now set up the pipeline. Now, let me quickly explain something to us here. Now, if you're deploying the image, right, to your EC2 instance, right, you need to know some things. all right, your key pair. Now, the key pair that we use to authenticate into this server, you need to find a way to get it onto our Jenkins server as well. And that's where this came from. All right. And then if you're SSHing, in order for you to not have that, this, do you want to continue fingerprint and so that we're typing yes for earlier, if you remember, that's where this thing comes from. So street host key checking equals to no. All right. So this will ensure that your Jenkins is able to log in into your instance without any kind of questions, whether it wants to continue or not. So let's go over to GitHub. Let's go over to GitHub. Let's see, and let's try and create a repository, right? Like I said, all of those apps, right, has been, they are available already on the GitHub repository, so you can go there to download it. But for the benefit of practice, let's just try to do another one. So let's call this React app. I'm just going to call this React app. So it's going to be a public image, and then I'm going to create a repository. So right here, it gives me a few commands that I'm going to run. So let's run these commands together. So the first thing we want to do is to initialize our folder. All right, so let's initialize it. All right. Okay, so let's open, we're going to have to open another terminal. Okay, so we're going to initialize. So the first thing is to do git init. So initialize this folder so that will make the folder a git repository folder. You can see that the whole thing changed to green immediately, right? So now the next thing we want to do, according to the instruction we have on the Git page, is to do a commit, right? So let's do our commit. All right, so let's do commit. But of course, before you do your commit, let's look at a few things. So if I do git status, so it shows me that I have a few files to add. So how do you add a file? So you can do git add. All right, so now it's been added. So if you look at it, so this file has been added. All right, so they need to be committed. So if I do git commit now, -m basically means I want to pass a message, right? I want to pass a message for this. So I can say React app post commit. So I press enter. So it has been committed. So the only thing I need to do now is to push it. So let's go back here and let's see the next instruction we have. So it's telling us to switch the branch to main, which it may not be necessary, right? You can leave it to master or main, whichever one it is. So the next one is let's copy this because we need to tell our application where exactly, the Git repository that it needs to push it to, right? Okay, so let's paste this right here. So we press enter. So basically what we have done is to say, this is where we want to push this application to. All right, so the next thing we want to do according to that instruction is to now push to the origin. So for example, if I just do git push, it's going to throw up an error. So it's going to give me a suggestion. So let's go with the suggestion. So git push. So it's asking us to set the upstream, right? Origin to master. All right, so that should push our application into that repository. So you can see that. So application has been pushed. And then if I go back to my Git repo here, all right, you can see now that I have my application. So it told us we just committed it 1 minute ago. So my applications is right here. So now I need to now connect this guy to my Jenkins, right? In order to build the pipeline. All right, in order to build the pipeline. Okay, now let's go over to Jenkins. So I need to copy this code here, all right, this URL. because Jenkins will need it. So let's copy that. So now over to Jenkins dashboard. Now, what we want to do is that we want to run what you call a multi-branch pipeline, right? A multi-branch pipeline. Now, let's click on new item. So I'll call this React app. And then I'll choose a multi-branch pipeline. And then I'll say, okay. All right, she's asking me for the display name. I can just call this React app. So what's the branch source? She's asking me, so I'll just say Git. And then I'll put the link here. Now, because it's a public repository, I don't need to specify any credentials, right? If it's a private repository, then you need to figure out what do you call it? The credentials on Jenkins. So quickly, let's look at how to configure credentials on Jenkins. So if I go to dashboard, let's click out. All right, if you go to manage Jenkins, you can actually scroll down and then go to credentials. So these are the different credentials that we have configured on our own Jenkins server already. So I have my Docker Hub credentials configured. Then I have a GitLab credentials configured as well. So if I want to configure any one, I can just click on this system right here. Click on this one, and then add the credentials. So basically, most of the credentials are username and password, so that's fine. So the username, you specify the username, right, for the account, and then you type in the password for that account, you give it an ID, and then you create it. So that's how you do your credentials in Jenkins. All right. Yeah. Now the git push original master basically means, okay, all right. Yeah. For those who are asking for the last recording, the recording is actually on the YouTube page. Let me see if I can just get the YouTube page now so that I can share it with us. Okay, I'll send the YouTube page link to us later on, and then we can get a video. The video is right there. All right. Now the git push original master basically means we are pushing, all right, to the master branch, right? So if you look at it here, this is the branch. If you look at the icon you have here, this icon basically just talks about branches, right? So we are pushing to master branch. That's what it means, right? If you look at the branches, we're pushing to master branch. That's what the git push. Now, because after you have committed all your code changes, now you need to push into your GitHub repository, right? So the git push original master just basically means we are pushing into the master branch. And the reason why we specified push original is because that is the first time we are committing something to that repository. All right. Now, for example, if I make any change, for example, let me just quickly show us something. For example, let's say, okay, let's just say I deleted something here. All right. So I've made a change. All right. Now, this change that I've made, now, if I want to push, I don't need to specify the original master again, or the origin rather. I don't need to specify the origin as master again. All right. Okay. Thank you very much. So somebody has posted the YouTube link. So you can just click on that. The videos is posted there. Thank you very much, Mr. Oluwatobi. All right. So I've made a modification here, right? So if I want to push this, I really don't need to. Now you can see that because I added it back, it shows me that there's nothing has changed. So if I delete this, it will show me here that this file has been modified. So if I want to push these changes, all I need to do is just to do what I can do. The first thing I need to do is to do git status, right? So it tells me that my script.groovy has been modified. So then the next thing I need to do is to add that changes, right? To add it. So I've added the change. Now, once you add a change like that, the next thing you do is to do what? Is to commit the changes. If you want to commit it, and then you can say Groovy script updated, right? So you've made your commit. Now, if I want to push, all I need to do is just to say git push. Now, I don't need to specify the origin as master. So I've done that once, and that's just what I need to do. So it is when you create a new GitHub repository at first, that's when you specify the origin as master. So subsequently, you only need to do git push, and that's what you need to do. I hope that answers your question. All right, so let's go back to our Jenkins. All right, so now, okay, so that's how you create the credentials in Jenkins. All right, now let's look at, so we're creating this pipeline for our React app. All right, and then now what we need to do again is, now don't forget, this pipeline that we're trying to build, we want this pipeline to also connect to our EC2 instance. So which means the same way I authenticated, right, with my EC2 instance on AWS, which I specified where my key pair was, and then I specified the username, all right, and then the IP address of my instance. I also need to do the same thing, all right? I also need to do the same thing, okay, with my pipeline as well. So my pipeline needs to have access, right, to the key that my EC2 instance used, right? So the private key that I used to authenticate with my EC2 instance, I need to find a way to also make sure that it is available on Jenkins, right? So how do you do that? So let's go to the dashboard. Now, this is the new hub that we're trying to build. So if I click on this guy, I need to make sure I find the credentials right here, right? So credentials is right here. So if I click on credentials, so I want to create the SSH credentials for this guy. So if I click on it, I'll click on here, and then I'll click on add credentials. Now, this credentials that I'm adding is only going to be available for this multi-branch pipeline, right? Nobody can use this. So I'll click on add credentials. Now, it's no longer going to be username and password because it's an SSH key, right, that we're trying to add. So SSH key is not username and password, so we need to also just choose SSH, username with private key. So that's the option you're going to choose. So click on that. The ID, so you can give it something reasonable. So let's just say AWS EC2 key, okay? The description, you can give it something also. So let's just say key pair to authenticate to EC2, right? So the username of that server, right? Now, remember I told you earlier, I said the server is running Amazon Linux 2023, right? So that means that the username is actually EC2-user. That's the username. All right, that's the username. All right, we'll shed more light on branching. All right, so just after, so let's just wrap up with this, then we'll shed more light on what branching is about. So now this is the username. All right, now here we need to put our private key here. So I'll click on enter directly, and then I'll click on add. So now I need to go and copy, right, the private key that I have on my system, the same one that I used to authenticate into my instance, right? I need to copy the content of that file and then paste it right here. So how do we do that? So let's go over here. Let's go back here and let us, the key is actually on my desktop, so I can go here and then I can say open file. So let's see, desktop, where are you? All right, this is my key right here. Okay, so I need to copy this whole thing. All right, so I need to copy, Control A, Control C, and then I would come back here and paste. Same thing right here. All right, so once that is done, I need to now do what? I need to now create it. So my SSH key is now available in my pipeline. So which means with this that I have done, I can now authenticate with my EC2 instance. Now, there's one more thing you also need to do. All right, one more thing to do. So let's go back to our React application and let's go to what we call a pipeline syntax. Now, we want to find a way to integrate. All right, we want to find a way to integrate. Well, the best thing you can do is when it comes to password like that, anything that has to do with password, SSH keys, and things like that, you must ensure that you find a place to keep them, all right, so that you don't miss it. All right. Now, something happened to me recently. Now, the Jenkins server that I am using and my Docker server, the key pair that I used, that I attached to them at first, I didn't know where where I just, maybe I deleted something and deleted them all, so I couldn't find it, right? Now, what I did in order to still be able to access my Jenkins server that you see now is to create what you call an AMI, right, from the original Jenkins server. All right, so I created an AMI, and then I now use that same AMI to go and launch, all right, another instance, and then I created a new key pair, which is the one we are using now, and then attached it to that, all right, the new instance. So that's another way that you can also recover if you forgot your key, but it's always good. And that's why AWS will always tell you, download it and put it in a safe place, because if you lose your key pair, you may not be able to recover your instance again. So it's important that you make sure that it is well kept, and then there are no issues with that. And then for somebody who was asking about branching, now in a real life environment, in a production environment, you're not going to just have one branch. The master branch that you have there is basically, just basically like what you can call the production branch, all right? The production branch, in the sense that everything, right, every application that you see, okay, every application that has been completed, that has been tested, that has been, approved by the different, authorities, everything is committed into the master branch, right? Now, in a real life environment, you're going to have maybe like 3, 4, 5 branches, because the purpose of Git is to enable collaborations, right? So people from different developers, they're going to be working on different things, right? So all of them are going to have their own branches. But at the end of the day, whatever code that they have completed and it has been vetted, it has been tested, everything is still going to be committed back into the master branch, right? Because it is the master branch that is connected to your production pipeline, right? If you look, this Jenkins pipeline that we are building now, I'm going to show us something. The reason why we are using a multi-branch is because if I create another branch, right, it should be able to, I can create another branch from that branch, and then that branch can be like an update branch. So anything that I do in the update branch, I can commit it back into the master branch. So the master branch is what connects to my production server. And so before you can move from any other branch to the master branch, there are levels of approvals that you will go through, because in a production environment, you must have your boss will be on the call, different people will be there. So anytime you make any commit, somebody must approve that commit before it enters into the production server. All right. So the master branch is just basically your production branch, and then you can have other branches as well. There are Git commands that you can use to create branches, right? If you want to create new branches, you can just do Git checkout -b and then the name of the branch. All right. But of course, the master branch is the main branch. Now, it can be master and it can be main. So if you see main, it's still the same thing as master, right? It's still the same thing as master. But basically what they are saying is that that is your main branch, right? Your main branch that connects to the production. I'm going to walk through the recovery again, right? Yes, of course, you need to, if you watch the video that we did, the last live class we did last week, Thursday, we did mention that, of course, before you can delve into DevOps, you have to, the first thing you start with is Linux. You need Linux knowledge. You need to be grounded in Linux, and then you move up to Git and some other skill sets like that. If you watch the video, I think somebody posted the YouTube page link. So let me see if I can get it. If you watch the video, you will be able to understand, where to start from as a DevOps engineer, right? So this is the link. So you can just go to the YouTube page and you'll find the information that you need there. So yes, you need some prerequisite knowledge before you can delve into DevOps. All right, that being said, let's go back to what we were doing. All right, now, the next thing we need to do is that we need to, because the code that we have committed into the Git repository, we cannot use that code as is, right? We need to still do some modifications to that code, all right? Because there are some things we need from our pipeline that will be in that code that we have not added yet. And one of those things is what you call, how you define your SSH agent, right? So if you go to pipeline syntax, so what we want to do is that we want Jenkins to generate some kind of code for us that we can use to authenticate into our EC2 instance, right? So here, I can go here from here and then type in S. So I'm looking for SSH agent, right? So it sees that, okay, I have a key there, and then I can click on generate pipeline script. So it tells me I need to add this, right, to my Jenkins file in order for my Jenkins to be able to communicate with my EC2 instance, right? I need to add that in order for Jenkins to be able to communicate with my EC2 instance. All right, so let's see how that works. All right, let's see how that works. Now let's go back to our scripts and let's do some modifications to our script. So we're going to copy just what I have in here. I'm going to copy this. All right, so let's go back to our script. Let me close this. Now, so if you look at it here, we have our SSH agent. So what I copied, I'm just going to replace that with this one. All right, so replaced. Now, our EC2 instance that we want to log into, the IP address has actually changed. It's no longer this IP address, so we need to change that as well. So let's go back and let's find the IP address of our EC2 instance. So for our Docker server, this is the IP address. This is the new one. So we copy that. And then we go back to our script, and then we replace with this one. All right. So Ctrl V. So we replaced it. Okay. All right. So now let's check through what we have so that we can do a few modifications. All right. So I can shorten this. I can just call it React app. All right. And then I can just call this React app, and then I can call these as well React app. Now, so let me just explain this thing once again. Now, what we're trying to do is we're trying to build a Docker image, right, from this Docker file. So this is the Docker file. So what the Docker file is basically doing for us is that we are packaging this application. This Node.js application is what we are packaging. We want to build an image from that so that the image can be run anywhere, all right? So we want to build an image from that. So we're packaging it using the Docker file. So that's the first thing that we're doing, all right? We're building an image, all right? And then this is the tag. So we're tagging the image so that if you want to use the image, we can easily use it anytime we want to use it. And then this dot, like I explained, the dot here means that there's a Docker file. This file is present in this present location, right? If the Docker file was maybe in another folder, I will have just put, dot slash and then the name of the folder and then reference the Docker file, right? But the dot basically signifies that the Docker file is present in that same directory. So after that is done, we now need to push the image to our Docker Hub repo, all right? Our Docker Hub repository, we need to push it there. Now, this with credentials is how you, how do I explain this? Now, this line right here is how you authenticate with your Docker Hub repo. Now, for those who may be familiar with ECR, if you want to authenticate with your ECR, now you're going to need access key and secret key. And that's going to be a long talk for this session that we're having. So that's why we are sticking with Docker Hub repo. That's still a bit easy for us to access. All right. So you need to define these variables right here. So basically, what you're accessing is the Docker Hub repo, which is somewhere here. Let me just show us that. So if I go back here to my Jenkins, where are you? Jenkins. So if you go back here to your credentials page, manage Jenkins, and then you go to credentials, you can see that I have my Docker Hub repo here, and I have the name and the password defined already. So basically, that script that I have there is only referencing this. So I am trying to call right, the username and password of my Docker Hub repo, all right, with that script. So that's what I'm trying to do. All right, so the credentials ID, right, is Docker Hub repo. And then the credential type is username and password. All right, it's not an SSH key, so it's username and password. And then the ID of that credential is this. And then the password variable, so pass username variable user, and then so all those ones. So from here, I'm saying login. So I'm trying to do Docker login from here. And so if the login is successful, so which means it's going to check this username and password that I've provided. If it is okay, if it corresponds with the username and password of my Docker Hub repo, then it's going to log in and then it's going to push this image that I've built here, is going to push it into that Docker Hub repo. So we're going to see that as well. So once that is done, the next thing we want to do now is to pull that image from the Docker Hub repo, right? We want to pull that same image from the Docker Hub repo. We want to pull it into, all right, we want to pull it into our EC2. So what we are saying is this, we're saying that, all right, this is just a message, then we're defining a function here. So this function is, all right, has this. So basically this is the variable, and then this variable contains this instruction, right? So if you look at it, we are referencing that variable right here. So this is basic, so this command here is actually going to run this whole line. So now, in order for us, for Jenkins to authenticate to our EC2 instance, all right, we need to do the SSH agent, just like we generated the pipeline script. And then we do SH, so the shell command. And then what we want to do, the shell we want to execute is just SSH-O, then street key checking equals to no, so that it will not be asking us whether you want to continue with the fingerprint or not and all that, because Jenkins cannot say yes to that, right? So we need to turn that to no so that everything can go on smoothly. Then we specify the username of our server and then the IP address of our server. And so once Jenkins logs in into the server, so what we are saying is that execute this thing right away, and then it's going to run, all right, it's going to run that image, all right, in a detached mode. So detached mode basically means it's not going to display any information on the screen for us to see, right? It's just going to run in the background. That's what detached mode means. So the port is going to be port 80. So basically what we're saying is that we are mapping port 80 on the Docker container to port 80 on our own server. Okay, on line 22. All right, I'm going to do that. Thank you for that observation. I'm going to do that right now. All right, so the name is this one. So the Docker that we want to pull is going to be React app, because we have changed the name here. So thank you for that observation. I appreciate that. So we have changed the name from here. All right, so we need to also change it from here so that I can pull the correct image. All right. So now I think all the modifications are complete. So if you look at it again, it tells us that our script.groovy file has been modified. So we need to push again to our Docker, to our Git repository. So what we need to just do is basically say Git. We need to add it first of all. So we're adding everything. And then we do Git commit. So we can say Groovy script updated. All right, so we put that in there. So we commit that changes, and then we just do Git push. So that pushes back to our repository. All right, so our repository is updated with the correct and the latest information. So let's go over to Jenkins and let's deploy the pipeline. Let's deploy the pipeline. All right, so here, okay, so these are Jenkins pipeline. We've already, this is the URL for the app. All right, so there's nothing more we want to do here. So it's telling us that the script part is Jenkins file, so which means the Jenkins file must be present in our, all right, so if let me just refresh this. So the Jenkins file should be present in our, all right, in our GitHub repo, so that Jenkins can do its own job. So we don't need this one anymore. We used it. All right, so that's okay. So we can do save. So Jenkins is going to scan. So it's scanning our multi-branch pipeline. So and then it's going to scan for the Jenkins file. So if it sees any Jenkins file, it's going to trigger a build. So if you look at it here, a build has been triggered. So if you click on this page right here, so a build is running, so something is going on right now. So let's see the console output. So it's going to be a long one, I'm sure. So something is going on right here. So if you look at it, wow. So let this thing let it be completed, and then I'm going to walk us through what all this is about. So Jenkins is already doing its job. It's doing what we have asked it to do. So let's just wait and let's see if this build is going to be successful or not. So Jenkins is doing its job. So it's pulling the image. So I'm going to walk us through all of these things once it's done. So let's see what Jenkins is doing. So you can see that all the things that we do manually, right? If you're doing this on your system, now you have to do all of these things manually. So Jenkins can do all of that for you. So that's the purpose of the CI/CD, and that's why, all right, organizations are moving to the CI/CD, because the process are automated, it is less prone to error and stuff like that. So it looks like pipeline was built successfully. So let's start from the beginning, right? So let's go back to status. Let's look at a few things. So let's go back to master. All right, so look at the build. So all the stages that we defined is actually what the build out. So the build stage, the push stage, and then the deploy state. So if I log into my Docker Hub repo here, we should be able to find that application right there. So let me log into my Docker Hub repo and let us see if indeed the application was pushed, all right, into the Docker Hub repo, and then if it was pulled from there as well. All right, so let me go to repositories. So this is my repository. You can see here, tell us that the last push was what? 2 minutes ago. All right, so, and then you can see the app is right here. So it tells us it was pushed 2 minutes ago, and then it was pulled, all right, 2 minutes ago. Okay, now let's examine the content of, where's the thing? All right, so this is our pipeline, everything built successfully. Now in a production environment, right, you're gonna have a longer pipeline. So you're gonna have like a code analysis pipeline where your code is tested, is verified to be sure that there are no errors in your code. Okay, so let's look at the build. Let's walk through the build. So the first thing Jenkins did was to authenticate with Git, and then it was able to pull the thing that we've put there already. Okay, the application that we put in there, so it was able to access that. And then we said it should build Docker image with Dockerfile. All right, so this is the command that we typed in. So it tells us that, okay, the Docker file was found. So you can see that, all right, it copied all of this, right? It walked through all of that step, and then it was successfully tagged, blah, blah, blah. So pushing Docker image to Docker Hub repo, we can see that from here that it was able to authenticate with our Docker Hub, right? And then it tells us that the login was succeeded. Yes, a Q&A actually has a role in the pipeline. Now, in a normal environment, in a production grade environment, now there are applications that, there's this open source application that they call SonarQube. I don't know if you heard about it. There's SonarQube. Now, you can build SonarQube into that pipeline. This pipeline that we just did, we can have SonarQube right there. Now, what SonarQube would do for us is that before the code or before the Docker image is pushed into the Docker Hub repository or any repository that you may have in your environment, maybe ECR repository or something, SonarQube is going to take that image, is going to scan that image for any vulnerability. All right. So if there are vulnerabilities with that image, now based on whatever logic that we program in our pipeline, SonarQube, right, may not allow the pipeline to proceed until the vulnerabilities has been fixed. All right. So in your pipeline, normally in a production environment, you're going to have what you call a Q&A, which is maybe a quality assurance, all right, or a code analysis kind of, so that you are ensure that whatever image that you are building, right? All the applications that you are packaging into an image, whatever it is, all the dependencies that you have in that image, you want to ensure that they don't have any kind of security risk that can affect your production environment. So in that same pipeline, yes, you're going to have a Q&A, quality assurance kind of, so you can use SonarQube. And then if you're using ECR also, ECR has a feature that is called scan on push. All right, scan on push. So which means the moment you push something into your ECR repository has the ability to scan that image for any vulnerability, and then it will show you the report if there's any error with that. So let me see if I have something like that in my ECR here. Let me see. I think I did one time like that. Let me see if I still have it right there. If it's still there, I can show us. Aha. So this is what I was talking about, scan and push. So if I click on this one now, can you see? So so you can see what ECR did. So ECR actually checked that image, and then it found a lot of vulnerabilities, right, with that image. Okay. So you can have that also within your pipeline. So you can see that there's one critical, 16 high, blah, blah, blah. So now, if you have all of these kind of things, as a DevOps engineer, it is not your duty to fix all these things. What you do is to basically call the attention of the developers to it so that they can fix all of these things. Because as a DevOps engineer, you are not a software developer, right? Your own job is to build the pipeline and to ensure that whatever code that they are developing, everything goes through the necessary processes and the necessary stages. So if you find an error like this after you have analyzed their code, your own duty is to call their attention to it and say, developer, right, these are the errors that we found in your code. So please check all of these things and then try and see if we can correct them, and then we can run this application again. All right, so it's not your duty to fix and start thinking, okay, how do I fix this? No, you basically call the attention of the developers to it, and then it is their job to fix it and to correct the error. All right. All right, so from here, the login was successful, and then the Docker push was implemented, and then so we pushed it to a Docker Hub repository. All right, and then the next stage is to deploy to the EC2. So using the credentials that we provided, was able to log into our EC2 instance, right? So if you look at it here, it tells us permanently added, blah, blah, blah. Normally, you should have asked us yes or no or something here, but because of this thing that we typed in here, it didn't ask all of that. So it tells us that image could not be found locally. So, hello? Hello? So it tells us that the image cannot be found locally. And then, so what it did naturally was to go to the Docker Hub, right, to pull that image for us. So you can see here that that was what was happening. So after the pull was complete, then the image was, right, run on our EC2 instance, and then our application is up and running. So now let's verify if indeed Jenkins did what we said it should do. So right here, we have our Docker server here. So let's go back to the Docker server. So here, now, initially, we didn't have any image or any kind of application running. So here, if I do Docker PS, I should have some containers running. So can you see that? So I have these containers running right here. So it shows that. So if you can look at it, this is the application that we just pushed. So it shows us clearly that Jenkins actually pushed the image onto our EC2, and then it ran the image, all right, and then made a container out of the image. So if I want to verify if this is working, all I need to do is just to type in the IP address of my EC2 server. So I can just go here to my browser and then grab the IP address of my EC2. So let's see, EC2, let's go back to EC2. EC2 instances. So my Docker server is right here. So let's grab the IP address of that. Let's paste it and then column 80. All right, we don't even need to do column 80 because HTTP is 80 already. So enter. All right, so we can see that our application, all right, ran successfully. Okay, so you can see what Jenkins is able to do. So that's what CI/CD is, right? So all of those manual tasks, all those things that you do manually by your own self, Jenkins can take care of those things for you. So here, this is just a simple React Node.js form. So I can just do, let's just do DevOps class and then DevOps at nn.com, right? So you can create a user, so you can see that the counter incremented that. And then you can add another one and say free class, all right? And then we can keep the same email and then create. So we have two. So if you click on get all users, right, it shows you all of the users that you have created. So now, if you look at what we have done now, the beauty of Docker is that we didn't have to install Node.js on our Docker server, right? We didn't have to install any kind of React, software on our server, right? Everything is being packaged inside of the Docker container. So if I want to access my container, it's pretty easy. I can actually access that container that is running. I can see what I have running inside of that container. So if I, this is the container ID right here. So if I click on that, all right, I can do what you call a bash just to log into it. And then I come back here and I do Docker exec, right? Then interactive, -u, then -0, right? Basically, I want to log into the container, right, as a root user. All right, so if I press enter, so I am inside of the container. Now, if I do node version, can you see? So node got installed on the container, right? Not on my local system, right? So if I do npm, which is also part of what we needed, version, can you see that? So all of those things that you need, all the dependencies that you need for your application to work, everything was installed, was packaged with the image, right? Because if you come here and you look at the image that we built, right, all those things, npm install from node and all of that, everything was packaged inside that image. So on my system, I didn't have to install node on my system. I didn't have to install npm on the Docker server, right? Everything was bundled, right, inside of the Docker image. And that's why you have all of it here. So if I exit out of this image, out of this container, right, and I type node on my normal server here, and I say version, it doesn't exist, right? So which means I don't need it. So which means if I take this Docker image and I give it to anybody, the only thing they need to have in the environment is the Docker runtime. So once you have Docker installed, you can run any image on your system. You don't have to install all the dependencies on your own local system, right? And that is one of the benefits that Docker provides, right? That's one of the benefits Docker provides. So you don't have to run all those things on your local system. Everything can be packaged inside of your Docker file. And then inside of your image, you have all those things installed inside of your image. And then if anybody should take that image and then they'll put it on their own system, it's going to work. Whether you are using a Mac, whether you're using a Windows, whether you're using a Linux, all you need is a Docker runtime. Once you have a Docker runtime, any Docker image will work on any operating system. Right. Yeah. Of course, you can do this without bringing in Jenkins, right? But of course, as a DevOps engineer, if you have a Linux server, I have a Linux server right here with me. I can actually run the same thing on my Linux server without bringing in Jenkins, right? But then that would be, it's going to be a lot of stress, right? Because if I can just have a Jenkins file or Jenkins script, all right, developed, and then to do the whole job for me, why do I have to stress myself unnecessarily? Because in a work environment, you're actually going to be using Jenkins, or you're actually going to be using what you call the GitLab CI/CD, which is becoming more popular right now, right? There's the GitLab CI/CD and there's the GitHub Actions. Those two things are becoming more popular at the moment. And so for the last free class that we're going to be having, which is next week, Thursday, we're actually going to be looking at the GitLab CI/CD. So we're going to be doing, a simple GitLab pipeline, right, with some GitLab CI/CD, because most organizations now are even moving away from Jenkins All right, they're moving onto GitLab CI/CD and GitHub Actions. All right, so for the last class that we're going to be having on the 25th, I guess that's next week, Thursday, we're going to be looking at GitLab CI/CD, how you can also run the same thing that Jenkins is doing, the same thing that we just did now, how you can do the same thing with your GitLab CI/CD. Yeah, you can use GitLab, you can use GitHub to put your code. They do the same thing basically, right? It's just preference. I just decided to use the last class that we did. I actually used GitLab to do that. So it's just a matter of preference. So you can use a GitLab, you can use your GitHub, whichever one you want. They do the same thing basically. GitLab, GitHub is the same Git command that works for all of them, right? Even if you're using ECR repository, right? Your ECR repository also uses Git command. Your Bitbucket also uses Git command, right? Your code commit and all those things uses Git command, all right? So it's just preference. Whichever one you choose, it's just GitLab, GitHub. They do the same thing. They store your code. Both of them as SCMs, right? They are source code management. All right. So lastly, let's just quickly. Yes, OSI model is important because as a DevOps engineer, you also need to understand networks, right? Now, if you look at the security group thing that we did, if you don't understand the way network works, all the port numbers, protocols, and all those things, it may be a bit difficult for you, right? So understanding the OSI model is important, all right, because with that, you can get to understand, the port numbers, the protocols, SSH protocol, what does it do at what level of the OSI model does it operate and also, yeah, understanding that is going to be useful, for DevOps. Yes, Mr. Della, yes, you can use the Dockerfile to build the Docker image locally as well, right? You can use it. Now, the reason I can't do it is because I'm using a Windows, and with a Windows, you need Docker Desktop to do that, right? But if you have a Linux system or a Mac, or even if you have a Windows too, and you have your Docker Desktop, you can also build the same image as well. Nope. All right, now let's just quickly do one last thing because I said we're going to be using the Docker Compose as well. So Docker Compose basically is what will help us to launch, multiple containers, right? So if you look at the Docker Compose that I have here, I have about 3 containers. I have my application, the one we just ran, and then I have a MongoDB image. I have a MongoDB Express image. So these are about 3 different images that I want to run. And I cannot run them, right, independently. I can't be running them one after the other, right? So I want to run all of them at once, all right? So Docker Compose is what will do that for me. But how do we do this Docker Compose? Now we need to make some modifications to our Groovy script, all right? But before then, let's try and, the container that we have here, Docker PS. Let's try and remove this container. We're not going to be needing it again, so let's just remove that. So the first thing, like I mentioned, is to do Docker stop. So if you have any container that is running, you do Docker stop to stop it. All right, you do Docker stop to stop that container. And then, so once the container has been stopped, then you remove it, and then you can then remove the associated image. All right, so the container has been stopped. So if I want to remove it, all I need to do is to do RM, all right? So RM is to remove containers. RMI is to remove images. So if I do Docker images, so I can also remove this image. So RMI. All right, so I can remove that as well. So let's clear this off. I'm going to answer all our questions. Let's just quickly wrap up this so that we can ask our questions. All right, so now what we want to do now is to use the Docker Compose in order to be able to access our application. So we want to just run multiple containers at once, and then we're going to be needing Docker Compose to do that. So now basically what we just need is just a single line, like I guess it's just a single line of code. that we need. So right here, yeah, your Docker file can be checked into a Git repository, right? Like GitHub or GitLab or AWS Code Commit, Bitbucket, right? Those are some of the SCMs, right? Source code management. So your Docker file can be stored into an SCM like GitHub, GitLab, Bitbucket, AWS Code Commit. Those are SCMs. Now, your Docker image is what you keep in a place like your ECR, Elastic Container Registry, all right? Docker images, you can't keep your Docker image in a GitHub repository or a GitLab repository. It's not ideal. So basically, where you put your Docker images, it's in a place that you call the ECR, Elastic Container Registry, or you use the online Docker Hub repository. But for most organizations that have the applications built on AWS, they actually keep their Docker images on Amazon ECR, right? Amazon ECR, okay? So now quickly, let's just add a few lines here. So we want to do Docker Compose. So what we want to do is that now this Docker Compose file that we have here, we need to find a way to, let me just do something. Okay, I have one here. So let me remove this. Remove then Docker. I want to remove that file. I actually have one there. So let me just remove it. Okay, it's gone. All right, so that everything is just clean. Now, we need to find a way to copy this Docker Compose file onto our EC2 instance, all right, so that our EC2 instance can launch the Docker Compose for us. So what we need to do is to provide a shell again, sh. Well, this time around, we are copying. So SCP. Now, your SCP just like a form of SSH kind of copy, all right? You want to do a secure copy. That's what the SCP means. You want to do a secure copy. So it also uses the port 22. All right. So somebody that was asking about the OSI model earlier. So these are some of the things, these are some of the reasons why you need to understand, networking basics at least. All right. So your SCP also uses port 22. And so what do we want to copy? We want to copy Docker. So the file is right here, right? The file is right here in the root directory. So we want to copy the Docker Compose file. Docker compose.yaml, that's what we want to copy. And then, so we are copying it to our EC2, right? Our EC2 user at, right, 3.8.39.48. So we're copying into that. But of course, we are copying into the home directory of our EC2 instance. So if I do here, I go back to my EC2 instance here, and I do pwd, which is the present working directory, and then it tells me this is my present working directory, so I can copy this, and then I can just come here and paste it, all right? So I'm copying the Docker Compose file that I have here into my EC2 instance, into the home directory. That's what I'm doing. Now, one more thing that we need to do. Now, this same -o that we added to this guy, we also have to include it to this one also to avoid any kind of issues, right? So we need to add it to it as well to avoid any kind of unnecessary issue. Now, the last thing we need to also do is to, now the way you run Docker Compose is different from the way you run your Docker, all right? The normal Docker, when you want to run a single image. Now, when you want to run a single image, you use this line of code, right? But for Docker Compose, it's a bit different because you are running a file, Docker Compose file. So let's change this to Docker Compose, all right, CMD, and then we're going to change what we have in here. All right, so instead of this, what we're going to have now is going to be Docker Compose, all right, file -f, so the name of the file that we're trying to run. So that will be Docker Compose.yaml. And then when you're running Docker Compose, you do up, all right? So up means start, right? When you say down, down means, all right, you want to shut it down. So up means to start it up, all right, to run that file. Basically, that's what the up means. And then you also want to run it in detach mode. Detach mode is just basically means you want to run it in background, right? That's what detach mode means. All right, so then we're now going to copy this and then replace it with this one here. So that's basically what we're going to run. So once Jenkins authenticates into our EC2 instance, it should run this Docker Compose for us automatically. All right, so that's the last thing we want to do. So now everything is set. So we need to commit again this code into our repository. So we do git. Oh, sorry. So here, all right. So we do git add. Oops. Git add. All right, and then we do git commit. So the message is that our Groovy script updated. All right, then we do git push. All right, so we're pushing it into the repo. Okay, so now if we, for example, if you want to create a new branch for this, you can do, let's say if you do git checkout -b, then you can give it a name of a new branch. So they can call this Docker Compose or something. All right, so it has switched to a new branch. So if I do git status, all right, so I can do git push. So if I do git push, it's going to throw up an error because I have moved, all right, from master, right, to what you call another branch, right? I'm just trying to do this for somebody that was asking earlier. So I created a new branch. So if I want to push to that branch, so I need to just do git push. So the same upstream. So I need to set the upstream now. So the origin for that is now going to be the new branch, right? Because we are moved to another branch, all right? Compose. So it's going to push into that new branch. Okay, so now if you go over to your GitHub, if you refresh, so your branches should be 2. So you can see the branches is now 2. So if you click here, so you now have the Docker Compose branch, all right, which basically contains the same code. I hope that answers your question now. So you have 2 branches created. All right, so that is how you can create a branch. Okay. So now let's quickly just do the next thing here so that we can, so let's see how the pipeline is going to look like. So for the Docker Compose, let's see what is going to happen with that. And then we take questions and comments. So if you go to React app and then you can do scan multi-branch. Now, you know, we have 2 branches now, and this is the multi-branch pipeline, right? So if I click on scan multi-branch pipeline, let's see what will happen. So if the scanning is correct, all right, so you should see a new branch right here. A new branch will appear here, and then it's building. Can you see? So the job is building. It's building the 2 because it saw changes in the 2. So if you click on this one, so you can see that we have a pipeline that is building. All right, so we have a pipeline building. So it's at the deploy stage. So if you click on that pipeline and go to console output, so basically Docker Compose should be doing its work, right? So you can see the Docker Compose is working, all right? So you can see that the copy command worked, and then Jenkins has been able to SSH into our instance. And so the Docker Compose is pulling some dependencies that is needed for that image to run. So you can see the whole thing that it's doing. So you can imagine running all of these things on your system and all that. So, right, that's why organizations are using all the CI/CD tool. You know, it's efficient, it's okay. You can track it, you can check who is doing what is doing. If anything should happen, if anything should break, is something you can actually monitor and know, you know, what happened and all that. So You can see all of the things that the Docker Compose had to do. And it tells us that the thing failed. Why did it fail? From daemon network, this is how the configures. Oh, okay. 2 matches found on name. So we already have some, I think I had some Docker Compose configured already. So let me just clear that off and then let's run the pipeline again. All right, so let's run it again. So if I do ls, okay, not here. So let's go back to Docker Server. So ls, we can see that our Docker Compose got copied right there. And so if I do Docker networks, what did I type? Sorry, Docker network ls. Okay. Oh, okay, we have 2 kinds of network there, and so there was a conflict. So which is why it didn't run correctly. So we can do Docker, let's do Docker PS, nothing started. So we can do Docker, let's see how we can remove this network. Docker network. We can also do some help. If you have any kind of thing you want to do, maybe you don't remember anything, you can also do help. So Docker command, then you can remove. So RM is right here. So this is what we want to remove. Network ID. So let's copy this. All right, so let's copy that. So we are removing this. So Docker network remove. Okay, so the network has been removed. So let's remove the other one. All right, so this is the other one. So Docker network remove RM. All right, so network has been removed. So if you do Docker network ls, so the networks are not there anymore. All right, so if you go back here, we can run our pipeline again. We can go back here and then we can build again. And hopefully this time around, the build will be successful. All right, so it's time for questions. For those that want to ask, so I'm muting us now so that if you want to ask your questions, you can go ahead and ask. All right, you can see that pipeline built successfully. So you can unmute yourself if you want. If you have any questions. Please go ahead if you have any questions.
Yeah. So thank you so much for the presentation. I have 2 questions actually. So the first one got to do with getting the syntax to encrypt the login into the Jenkins file. As to, I don't know if you've come to the Jenkins GUI to generate the syntax to include it in the Jenkins file. So I don't know how you are able to encrypt the login details. The second question is, you've taken all the time to build your Docker file and to build your Docker Compose. What prevents you from just going ahead and then running all of them in your Docker server, and still you can be able to access them wherever you want, right? So like bringing in the whole Jenkins, which I think has rather make the process a bit complex, is what, like, if you can explain that to me, I'll be very grateful.
All right. Let me just quickly attend to that question. Now, the reason why we had to bring in the Jenkins is because if you get a job as a DevOps engineer, right, you're not going to be doing all those things on your system on an EC2 server, right? You are going to be doing it using a CI/CD tool. And Jenkins is one of the CI/CD tools that is still popular out there, right?
Okay.
So that is why you need to understand Jenkins. Now, if you're in DevOps, right? If you're in DevOps, there's no way you won't know how to use Jenkins. And that is why I said in the next live class that we're going to be doing next week, we're going to be looking at GitLab CI/CD. Because as a DevOps engineer, these are the things you need to understand how to use. You need to understand how they work. All right. You need to understand all of those details. All right. So what we're trying to do is that we're trying to model a real world environment, right? Because in a real world, you are not going to be using your system to build it. Now, let me show you something here. Now, I have another system right here that is a Linux system. So let me just show us that, okay? Let me stop recording so that that one can be processed. Now, let me just show something here. All right, sharing master panelist. Yeah. Now, now look at this. This is a Linux environment, right? If you look at this is a Linux environment. So whatever it is that I want to build, I can actually build it here. If you look at these, I've actually run a few scripts on my Linux environment. So here I can do whatever it is that I want. So if I do sudo su, right? Let me just put in my password. All right, so let me play this. So now here, if I want to build my Docker file, I can actually build a Docker file, right? I can just simply say Docker build -t, and then I can give it a name, and I can say node app :1.1, and then put in the dots to signify my Docker file, right? So if I press enter, the same thing Jenkins is doing is what it will do. So look at what it's doing here for me, right? But of course, in a real world environment, you're not going to be building your application on your laptop. You're going to be using the Jenkins CI/CD, GitLab CI/CD, GitHub CI/CD. And that is why it is important for you, if you want to be a DevOps engineer, to understand how to use all of those tools. Now, they are not complex, right? If you start using it, if you start learning all those things, right, it becomes easy, okay? It is because maybe you've not picked it up before, right? But you start picking it up now, then you start learning, you start practicalizing and all that. Before you know what is happening, after like 2 months or thereabout, you also become a pro, and then it becomes very easy for you, right? And that's why we have a class that is starting later this month. So for those who are interested.
Okay, so I get your points clearly, but this is your local environment that you are using. But maybe in a work environment too, you might provision an EC2 instance where you install your Docker to become your Docker server, on which you can use the Docker Compose app to spin up all these containers on your Docker server. And from there, as long as they are running container, you could access them using your IP address and your assigned port number. So I have used Jenkins a little, but not in the advanced stage, but in a little way. But as to like, if you could, like, as you've just build an image, and you can run this image, and also if it is a web server or whatsoever it is, you can be able to run this image into a container, and then you could access it using the IP address, the assigned IP address to that container, as well as the assigned port number that you have assigned yourself. So if you could do that, if you could do this over here, which is your local repo, you could as well do that on an EC2 instance that you can provision and have your Docker on it, and do the same thing over there. So it's not more like you are performing those tasks on a local on a local server, but rather a provisioned EC2 instance. Maybe if you are working in the AWS environment, that's an EC2 instance with Docker installed on it as the containerization tool. I don't know if you are getting my point.
Yeah, I understand what you're saying. I get what you're saying. You can use an EC2, yes, but you know, if you're using an EC2, for example, your EC2 does not come with a code, a VS Code, right? A VS Code editor. So how do you edit your code? How do you edit your Docker file? Because if you're
you SSH into your EC2 on your VS Code.
I understand that. If you SSH into your EC2 and your VS Code, right? But what I'm just saying basically is that in a normal work environment, in fact, in most production environments, they don't even use an EC2. You have what you call, you know, there's ECS and there's EKS, right? So normally you are supposed to even have your Kubernetes manage all of those things for you in the first instance, right?
Yeah.
But this one is just like more like the basics, just to get people familiar for those who are not familiar with DevOps, who are trying to get into DevOps, all right? So that's why we are doing all of these ones. But in a normal work environment, the pipeline is going to go from your Jenkins or from your CI/CD or from your GitLab CI/CD. It's going to deploy to your Kubernetes cluster. Now, your Kubernetes is going to be the one that will now decide, you know, if you are using EC2 instance or you're using Fargate, the Kubernetes is what will decide which of the instance is going to run, all right? That's the ideal production system. That's how it works.
Yeah, accepted way. Okay. So my second question is with the Jenkins file. If you could do me the honor to like open it, there's a place that you brought in login credentials, a lot of things, which the actual passwords are not showing. That means you have saved them as variables somewhere, which you are calling.
Yeah, that's what I showed us. I showed us earlier now on the Jenkins server.
So you generated those things from the Jenkins server itself, right?
Yes, on the Jenkins server, you have to there's a credentials section on the Jenkins server, right? Where you provision all your credentials, and then you are just referencing those credentials. That's what you're doing.
Okay. Thank you.
Basically, yeah. All right. Somebody asked a question about Maven something. No, you don't need to do Maven clean install, because what we are dealing with is a Node application. We're not doing a Java, we're dealing with a Node.js application, all right? We are not trying to build a Java application. So in this case, we don't need to do a Maven clean install, right? Because what we are doing is just basically a Node.js application. So Node.js uses NPM as its own package manager. So NVM that you're mentioning here is used for Java applications, all right? That's what they use NVM for. But since we're dealing with a Node.js application, we're going to use NPM, all right? That's what Node.js uses. Okay, what ticketing system is used in DevOps, and is it important? Well, for DevOps, you have things like that you call the Jira board or something, where you have your information displayed, what you are doing at the moment and all that. Now, before you can even go to all the Jira board, Splunk and all those things, of course, you must be grounded in all the basic tools, right? If you watch the video that we did in last, I mentioned, you know, the pathway that I feel it's better for somebody that wants to become a DevOps engineer. At least your Linux, you must be solid, because if you look at all the things that we've been doing today, we've been typing commands here and there, you know, all those things. So if you don't have a solid Linux background, you're going to have issues. So before you can think of the ticketing systems, right, you must of course be familiar with the major tools, right? Your Ansible, Kubernetes, Docker, Terraform, and all those kind of things. So all those Jira are just, you know, extras, right? They are just extras that you can also add to your, you know, to your belt, right? So there's the Jira board and all those kind of stuff that they use for ticketing DevOps, right? Any other question? Do we have any other questions, please? You can unmute yourself and ask your question.
Hey, hello. Thank you very much for the call. I mean, me joining the call is really, starting from scratch, to be honest. I'm very curious. I've been following a lot of DevOps content, but this session was really to clarify a lot of points and seeing it in action, like a practical way. because as it's still new, a lot of people are not disclosing a lot of, practical way of doing it. But coming from a background of web services, doing web development, mobile development, I start understanding very well the idea of, using Docker and the containers, because it just helps you generate, all the frameworks, just like you see, all the dependencies. And that's really amazing. And I'm really excited to continue, looking at the previous videos you uploaded and also assisting to the next sessions, definitely. So thank you very much for this.
All right, thank you very much. I really appreciate that. And of course, like I said, the reason why we're doing this, we have a training that is coming up. And for me, I believe people should be able to make their choices, right? You can't just tell them there's a training coming up and then you expect them to just come and then, pay and then do the training. No. So that's why we are having all of these sections, right? So that people can just have an idea of what, if they are going to join the training, at least just come and see what the training is going to look like. And then if you do make that decision, then of course, you have made, a good decision. So thank you for that comment. And so the last, so next week, Thursday, we're going to be having the last free section because the class is going to start fully on the 31st of May. We're going to be kicking off the class on the 31st of May. And so, so next week, Thursday, we're going to be looking at GitLab CI/CD. Like I said, for me, sometimes, I do attend a few interviews just to understand what organizations are doing, what are the best practices, what are they moving into. So there was this one I attended, and then the person said they were moving into GitLab CI/CD. All right, so some organizations are beginning to drop Jenkins, and then they are moving to GitHub Actions and GitLab CI. So we're going to build a simple pipeline on GitLab CI/CD, right? We're going to build just a simple pipeline for GitLab CI/CD and see how that works compared to Jenkins. Now, with Jenkins, there's a lot of plugins to install. But with GitLab CI/CD, you have the concept of runners and stuff like that. So it's a bit easier. And then, it makes a lot of sense. All right. So next week, Thursday, we look at that, and then that will wrap up the. All right. Thank you very much, sir. Thank you very much, sir. So that will wrap up the all free classes. And then all the videos are available on YouTube, the the code repo. Also, you can download it and then try it on your own system and see how it works and all that. So you can give it a try. The videos are there. You can watch it. And then the repository is also there. Let me see if I can get the GitHub repo. Let me see if I can get a link. Okay, Mr. Dela, right? I think he's raising up his hands.
Oh, let me lower it. Let me lower it.
Oh,
I
okay.
think even the GitHub repo URL is included in our email. The email to
yes, I sent out an email. I don't know if people received it, but I try as much as possible to send out.
Yeah, everything is included in the email.
Okay.
Yes,
Right.
yes.
Thank you for that information.
Thank you very much.
This video that we have done, it's going to be available on YouTube maybe by tomorrow or so, because it still has to go through a few process and all that. And then, but by tomorrow, it should be available on the YouTube page. So you can just go there and watch and help us, subscribe to the channel and tell people about the training as well. If you have people who are interested, just let them know they can watch the videos and then make their decisions themselves.
Thank you.
All right. So do we still have any more questions? Okay. All right. Thank you for the comments, sir. We appreciate you. So this is the website. Let me just send you the website where you can get all the information regarding curriculum and payments. All right. So that's the website.